Hi guys, welcome to this geometry review video. In this video, I'll be going over regular polygons, triangle theorems, and points of concurrency. First, let's talk about regular polygons. A regular polygon is a polygon where all sides and angles are congruent. So below I have a few examples. Equilateral triangles, squares, and regular pentagons are all regular polygons because they all have congruent sides and congruent angles. Two important things we need to know about regular polygons are interior angles and exterior angles. Let's start off with the interior angles. To find the sum of interior angles, we can use the equation n minus 2 times 180 degrees, where n is the number of sides the regular polygon has. To find the measure of each interior angle, we can just take the sum of interior angles, which is n minus 2 times 180, and divide it by the number of sides. Keep in mind that each interior angle cannot be greater than 180 degrees. Okay, here are two practice problems that I'll be going over. Feel free to pause the video and try them on your own. Okay, what is the sum in degrees of the measures of the interior angles of a pentagon? So we know that a pentagon has 5 sides, and the equation to find the sum of interior angles is equal to n minus 2 times 180. So we just plug in 5. 5 minus 2 times 180 is equal to 540. So the answer is C. What is the measure of an interior angle of a regular octagon? We know that an octagon has 8 sides, and to find the measure of one interior angle, we first need to find the sum of all the interior angles. So we can just do 8 minus 2 times 180, which is equal to 1080. And to find one interior angle, we take the sum and divide it by the number of sides. So 1080 divided by 8 is equal to 135. So the answer is B. Moving on to exterior angles, the most important thing to remember is that the sum of exterior angles is always 360 degrees, no matter how many sides the regular pentagon has. So to find the measure of each exterior angle, we just do 360 divided by the number of sides. And here's just a diagram to show you where the exterior angle is. What is the measure in degrees of each exterior angle of a regular hexagon? So we know that a hexagon has 6 sides. So all we need to do to find one exterior angle is just do 360 divided by 6, which is equal to 60. So the answer is C. One piece of the birdhouse that Natalie is building is shaped like a regular pentagon, as shown in the diagram. If side AE is extended to point F, what is the measure of exterior angle DEF? So we're trying to find the measure of one exterior angle, and we know that this is a regular pentagon, so it has 5 sides. So all we need to do is just 360 divided by 5, which is equal to 72. So D is your answer. Okay, next, let's move on to some important triangle theorems. First, we have the triangle inequality theorem, which tells us that the sum of any 2 sides of a triangle is greater than the third side. And if this condition is not met, the 3 sides cannot form a triangle. So if we take a look at this diagram right here, if we take the measure of side A and add it to side B, it has to be greater than side C. And if we take side A and we add it to side C, it has to be greater than side B, and side C plus side B has to be greater than side A. So any 2 sides added together has to be greater than the third side. Which numbers could represent the lengths of the sides of a triangle? So according to the theorem, the sum of 2 sides has to be greater than the third side. So we can just go through each answer choice to see where that is true. So 5 plus 9 is equal to 14, which makes the sum equal to the third side. So number 1 is not the answer. 7 plus 7 is equal to 14, which is less than 15, so 2 is not the answer. 1 plus 2 is equal to 3, which is less than 4, so 3 is not the answer. 3 plus 6 is equal to 9, which is greater than 8, so number 4 is the answer. In triangle ABC, AB is equal to 5 feet and BC is equal to 3 feet. Which inequality represents all possible values for the length of AC in feet? So if we have triangle ABC right here, if AB is 5 feet and BC is 3 feet, we know that the sum of these two sides has to be greater than AC. So we can set up an inequality. So we know that AC has to be less than 8. So looking at the answer choices, the only one that shows that AC is less than 8 is number 2. Okay. Moving on to triangle theorems. The isosceles triangle theorem says that if two sides of a triangle are congruent, then the angle opposite of those sides are congruent. So if we have a triangle right here, if these two sides are congruent to each other, then the angles opposite of them are also congruent to each other. And the converse of this theorem just says that if two angles of a triangle are congruent, then the sides opposite of those angles are also congruent. Okay. In the diagram of ABC below, line AB is congruent to line AC. The measure of angle B is 40 degrees. What is the measure of angle A? So we know that line AB is congruent to line AC, and the measure of angle B is 40 degrees. And since line AB is congruent to line AC, that makes angle B congruent to angle C. So angle C is also 40 degrees. And we're trying to find the measure of angle A. And to do that, we're going to have to do 180, which is the total number of degrees in a triangle, minus 40, and then minus 40 again, which is equal to 100. So the answer is number 4. The diagram shows the roof of a house that is in the shape of an isosceles triangle. The vertex angle formed at the peak of the roof is 84 degrees. What is the measure of x? So since we know this is an isosceles triangle, we know that these two lines are congruent to each other, and that angle x is going to be congruent to this angle. To find angle x, we can do 180 minus 84, which is equal to 96. And 96 is the sum of angle x and the congruent angle over here. So we can just do 96 divided by 2 to find angle x, which is equal to 48. So 4 is the answer. Next is the mid-segment theorem, which basically says that the mid-segment between any two sides of a triangle is parallel and half the length of the third side. So I'm going to just draw a triangle to help visualize. Okay, the mid-segment of a triangle is the segment that connects the midpoints of two sides. So we can try to find the midpoint for AB, which would be around here, and then the midpoint for AC, which would be around here. So if we connect these 2 points, that is our mid-segment, and the theorem basically tells us that this line is parallel to the third side, which is BC, and is also half the length of BC. So if we were to label this D and E, line DE would be equal to half of line BC. In triangle ABC, D is the midpoint of line AB and E is the midpoint of BC. If AC equals 3x minus 15 and DE equals 6, what is the value of x? So DE is the mid-segment and AC is the third side. We know that DE is equal to 1/2 of AC, and D is 6 and AC is 3x minus 15. So all we need to do is just solve for x. 6 times 2 is equal to 12. 27 equals 3. So x is equal to 9, which makes 3 the answer. Triangle ABC is shown in the diagram below. If DE joins the midpoints of ADC and AEB, which statement is not true? So number 1 says that DE is 1/2 of CB, which is true according to the theorem, since the midsegment is 1/2 of the third side. Number 2 says DE is parallel to CB, which is also true according to the theorem. Number 4 says triangle ABC is similar to triangle AD. So this big triangle is similar to this triangle, which is true because, let's go back to our old diagram. So since D is the midpoint of AB, then that means that these two lines are congruent to each other. And then since E is the midpoint of AC, these two lines are congruent to each other. So AD right here is 1/2 of this bigger segment, and AE is also 1/2 of this longer segment. And we know that according to the theorem, the midsegment is 1/2 of this long segment BC, which makes this smaller triangle ADE similar to the bigger triangle ABC. So going back to this question, number 4 is actually true, so we can cross that out. And number 3 is the answer. Now we'll be going over the points of concurrency. The first point we'll be talking about is the circumcenter, which is the point where the perpendicular bisectors of the sides of the triangle intersect. This point is equidistant from all 3 vertices and is the center of the circumcircle. So let's just say this acute triangle is triangle ABC. The perpendicular bisector for AC would look something like this, where this is perpendicular and these two sides are congruent to each other because this is a bisector. And for AB, something like this. This is perpendicular and these two sides are congruent. For BC, and the point where they all intersect is the circumcenter. So for a right triangle, it's gonna look something like this. These are all perpendicular and congruent. And right here is, and then for the obtuse triangle, okay, as you can see, the circumcenter can be inside, outside, or on the triangle. So for right triangles, the circumcenter is always going to be on the triangle. For acute triangles, it's always going to be inside the triangle, and for obtuse triangles, it's going to be outside. This point is the center of the circumcircle, which is basically a circle that intersects with all the vertices of the triangle. So it looks something like this, and the circumcenter is the center of that circle. The next point we're going to go over is the centroid, which is the point where the medians of the triangle intersect. The median is drawn from the vertex to the midpoint on the opposite side. The centroid divides each median into a 2-to-1 ratio. The longer segment is closest to the vertex. Okay, so to draw the medians of the triangle, we can start off at a vertex, and we have to draw it to the midpoint of the opposite side. So this is the midpoint, and it splits BC into 2 congruent segments. And from B to the opposite side, it would look something like this, where it splits AC into 2 congruent segments. And C, it would look something like this, splitting AB into 2 congruent segments. So this is the centroid. So it says that the centroid divides each median into a 2-to-1 ratio. So let's just label these points D, E, F. So for the median AE, the segment GE, if the value was 2, then the value of AG would be 4. If the value of DG is 5, then the value of GC is going to be 10. So the value of the shorter segment is always going to be 1/2 of the larger segment because it's in a 2-to-1 ratio. So again, let's just say GF is 3, then BG is going to be 6. The next center is the orthocenter, which is the point where the altitudes of the triangle intersect. The altitude is a perpendicular segment from a vertex to the opposite side. And like the circumcenter, the orthocenter can be inside, outside, or on the triangle. So let's just start off with this acute triangle. We start off at the vertex and we try to make this line perpendicular to the opposite side. And same for this vertex. Has to be perpendicular. So that is the orthocenter. And for a right triangle, we can start at the right angle. So that is a perpendicular segment. Okay, so for this vertices right here, to draw a perpendicular segment from that vertex to its opposite side, which is this side right here, the segment would look something like this. So it's perpendicular to the opposite side. And same goes for this vertex. It's gonna look something like this. So it's perpendicular to the opposite side. So the orthocenter for a right triangle is always gonna be at the vertex where the right angle is. And for obtuse triangles, we can start off with this angle right here. And it's gonna look something like this. For this vertex, again, to create a perpendicular segment, it has to look something like this. So it's perpendicular to this side right here. And for this vertex, it's gonna look something like this. We can extend this so that the points can connect. It's not a really accurate drawing, but if it was well done, then the lines should match up right here. So this is the orthocenter. And again, like the circumcenter, the orthocenter can be inside, outside, or on the triangle. So for right triangles, it's always going to be on the vertex where the right angle is. For acute triangles, it's going to be inside. And for obtuse triangles, it's going to be outside of the triangle. Okay, moving on to the incenter, which is the point where all the angle bisectors of the triangle intersect. This point is equidistant from all three sides and is the center of the incircle. So the angle bisectors would look something like this and would make these two angles congruent to each other. These two angles would be congruent to each other. And this is the incenter. It says that this point is equidistant from all three sides, which means that this segment right here, here, and right here are all congruent. And it also says that it is the center of the incircle. The incircle is basically just an inscribed circle in the triangle. So the incenter is the center of that circle. In the diagram below of triangle ABC, line CD is the bisector of angle BCA, AE is the bisector of CAB, and BG is drawn. Which statement must be true? In the diagram below of triangle ABC, CD is the bisector of angle BCA, so that means that these two angles are congruent to each other, and AE is the bisector of CAB, and BG is drawn. So since this question is talking about angle bisectors, we know that this point right here is the incenter. So which statement must be true? So number one says that DG is equal to EG, which is not true because the incenter is not equidistant from all three sides. Number two says HG is equal to BG. So this line is congruent to this line, which is also not true because the incenter is not equidistant from the three vertices. Number three says angle AEB, which is this angle right here, is congruent to angle AEC, just this angle right here, which is not true. Number four says angle DBG is congruent to angle EBG. So this angle right here is congruent to this angle, which is true because if you extended BG, it intersects with the incenter, which makes it an angle bisector. So the two angles are congruent to each other. So number four is the answer. Triangle ABC is graphed on the set of axes below. What are the coordinates of the point of intersection of the medians of triangle ABC? Triangle ABC is graphed on the set of axes below. What are the coordinates of the point of intersection of the medians of triangle ABC? So this is talking about the centroid. And to draw the medians, we start off at the vertexes and we draw it to the opposite side's midpoint. Okay, so starting from A, the median would look something like this. And for B, it would look something like this. And C is going to look something like that. So approximately, we can say that the centroid is at this point, which is at -1, 2. So number 1 is the answer. The diagram below shows the construction of the center of the circle circumcised about triangle ABC. So immediately we know that this is talking about the circumcenter, because this is the circumcircle. This construction represents how to find the intersection of... Okay, so remember that the circumcenter is the intersection of the perpendicular bisectors of a triangle. So the answer is number 4, the perpendicular bisectors of the sides of triangle ABC. In the diagram below of triangle ABC, line AE is congruent to line BE. Line AF is congruent to line CF. And line CD is congruent to line BD. Point P must be the... So we know that triangle ABC is an obtuse triangle. And we know that in an obtuse triangle, the circumcenter and the orthocenter always lay outside of the triangle. So immediately we can eliminate answer choices 2 and 4. The incenter has to deal with angle bisectors. And the centroid deals with medians, which split a line segment into 2 equal segments. So number 1 is the answer.